Hello guys, in this video we are going to be rewriting expressions using our log laws. In this video it's going to be different because we're going to be going from single logarithms to multiple logarithms. Let me show you what I mean with an example. So, for the following examples we want to express in terms of log to the base a of x, log to the base a of y, and log a to the base a of z. Okay, so we want to express the following like that. Let me show you what I mean. So the first example we will look at is this. We have log to the base a of x, y, z. Using our laws of logs, we're going backwards to say that this is the multiplication law, so we can rewrite this as log to the base a of x plus log to the base a of y plus log to the base a of z. Okay, that's just the starting example. Okay, let's look at another example. Let's take this one. Let's take log to the base a of x to the power of 4, y to the power of 5. Okay, so the first thing we notice is we have x's and we have y's. So what we're going to do is we're going to consider the multiplication law, which will make it become log to the base a of x to the power of 4 plus log to the base a of y to the power of 5. But we're not done yet because this isn't in the form log to the base a of x. This is with in terms of x to the 4 and y to the 5. So we need to finally use our power law to rewrite this like this. We write it as 4 log to the base a of x plus 5 log to the base a of y. And that's what we are looking for there. Okay, let's take another example just to keep the ball rolling. Let's take this example. Let's take log to the base a of x cubed y to the 4 z. Okay, so if you'd like to pause it and have a go, I'm about to have a go now, and I notice that there is the multiplication law which we can use first. So we write this as log to the base a of x cubed plus log to the base a of y to the 4 plus log to the base a of z. Notice how I put lines through my z's. The reason I do that is just so that I don't get confused between a z and a 2. Okay? Right. So we've got that. Again, the log to the base a of z is fine, but the x cubed and y to the 4 are not fine because it's not in terms of x and y. So we use our power law, and that becomes 3 log to the base a of x plus 4 log to the base a of y plus log to the base a of z. Okay. Right, let's take another example. We'll go through 2 more. So let's take log to the base a of x to the 4 over y squared. Let's just make that too clear. There we go. Okay, so this one is a division, as we can see, so we're going to use the division law. So going backwards, we can see that this is the same thing as log to the base a of x to the power 4 minus log to the base a of y squared. Again, we're not yet done because it's not in the form of x, log to the base a of x and log to the base a of y. So we use our power law to say 4 log to the base a of x minus 2 log to the base a of y. Right, let's look at a few more examples, a little bit more complicated. So let's take this one. Let's take log to the base a of x y cubed, like that. Now this one looks that little bit more complicated, but actually it's not so bad. What we're going to do here is we're first of all going to deal with the xy to the power 3. Using our laws of indices, we can rewrite this as log to the base a of x cubed y cubed, and then we can say that's equal to log to the base a of x cubed plus log to the base a of y cubed. That's just again using your log laws. But again, we're not done. We need to rewrite this in terms of log to the base a of x and log to the base a of y. So we write log to the base a of x with the 3 in front, plus again for this one, 3 log to the base a of y. Okay, 2 more examples. Let's take this one. So we'll say, this one says log to the base a of x over z root y. Okay, so this one again looks a little bit more complicated, but we've got a division, so let's deal with the division. We've got a numerator and a denominator, so we can rewrite this as log to the base a of x minus log to the base a of z root y. Okay, now we just need to separate out the z and the root y, so that's going to become log to the base a of x minus, because there's a minus, I'm just going to be careful here and put a bracket and rewrite this as log to the base a of z plus log to the base a of root y. So again, using that multiplication law, but I've put a bracket there just to ensure that that minus applies to both of these things. Otherwise, people tend to forget. And then I can say this is log to the base a of x minus log to the base a, log to the base a of z minus log to the base a of root y. Okay, and again, the x and the z are fine, but the y isn't. We need to rewrite this using our power law, so that becomes log to the base a of x minus log to the base a of z minus log to the base a of y to the power of a half. Remember, the square root of y is the same thing as y to the power of a half. And then finally, using our log laws, we can rewrite the last bit with a half as a coefficient. So our final answer becomes log to the base a of x minus log to the base a of z minus a half log to the base a of y. Okay, that was quite a more complex example just because it was a little bit longer, and then we'll finish up with this one. So let's suppose we have log to the base a of the square root of xy. Here we've only got x and y to deal with, so that shouldn't be a problem. We rewrite this using our laws of surds or indices, however you want to look at it. We can look at it like this. So we can say this is log to the base a of root x, root y. That's a surd law. And then we can say that's equal to log to the base a of root x plus log to the base a of root y. Okay, and then again we use our laws of indices to rewrite the square roots as powers of halves. So log to the base a of x to the half plus log to the base a of y to the half, and then that becomes a half log to the base a of x plus, plus a half log to the base a of y. Okay, hopefully that gives you a bit more of an idea of how to work through these. Again, feel free to look back through the video just to see some of the examples that we did and some of the steps that we did. Understanding this will be really useful when it comes to solving some more complex equations involving logarithms. Okay, that's it for now.